Good morning, everyone. So today we are going to present about Mittrapol Plastic Company. It is an SME experience in producing plastic for 28 years, the leader in the plastic bag printed plastic bag production company and distributor.
So for the current state, the company current production method is that when they decide to use the machine in either process, they are required to produce and use it with full capacity or not producing at all. Next is the working process. In Mittrapol plastic factory, it is separated into three parts. First process is drying, second is printing, and third process is cutting.
In terms of the problems, as my colleague has mentioned that the company is currently undergoing production with their own method, as they have a policy where their regular production is a binary at either 0 or 100% of their capacity. So the first problem is that they want to know if there is a different production schedule and strategy that they can employ to minimize the cost and maximize the profit for the week. Secondly, due to the COVID-19 situations, the company expect that there will be the volatile change in their demands of their plastic bag productions. So the company wants to know what other suggestions or strategy that they can use to handle with the exceeding demand or the decreasing substantially. For the exceeding demand or the best case scenario, the company suggests to either outsource their leftover productions or add an additional workday to the week to increase the capacity, and want to know which one is more profitable. For the decreasing demand, they want to know whether or not the running at their current full capacity policy is still a good idea to implement. And the final problem is that if the company wants to add another product type into the third process, they want to know the amount of the company should produce for two different types of the plastic bag products to maximize the profit.
Moving on to management science method, we are using linear programming for production scheduling. Here's our constraints of production values. Our objective is to maximize the total profit and minimize the total cost. The model only represents 6 working days, and most of the models include only one product line. However, the 2 product line model represents 2 product types. True product line models constrain with production from previous process and available hours instead of process 3 capacity, no waste or reject product in production. We came up with this methodology by creating 2 models to represent the company's production schedule. The first contains binary and normal decision variables to represent the amount produced in each station and hour, which we use to calculate the total cost and profits. The second model expands on the third process in Model 1 and includes decision variables of the amount of product type produced. For 2 different types of plastic bags, we find the optimal amount of each product type by split into decision variables for each work hour type. These are constrained with work hour limits, then consolidated into margins and cost to find total profit.
So we have tested out our model in solver and the result is as follows. First, we tested out the full capacity policy on normal circumstances where demand are 1,450 kilograms per week. The total cost incurred would be around 252,000 baht, and for worst case scenario where demand is reduced to 950 kilograms, the cost of production is 171,000 baht. After that, we try implementing the new policy, which is to produce only to meet the demand, not required to use the machine in full capacity. The result given by solver is pretty remarkable as the cost in normal case is lower by 10,000 comparing to full capacity policy. And for the worst case, it is lower by 20,000. For best case, I have separated as the demand for this scenario is higher than our available capacity. Our maximum production in 6 working days is only 1,800 kilograms due to the second process capacity limit. And the demand in the best case is 2,000 kilograms per week. So both old and new policy will be forced to produce in maximum capacity and the cost will result the same anyways. But in order to satisfy the demand, we have 2 options to choose, which is outsourcing other company to do the remaining demand or open Sunday as a working day. We have used solver on the 2 model and the feasible solution gave us the cost for both of the option. If used outsourcing for the remaining demand, it would cost us 341,000 in total. And if we open Sunday as another working day, it would cost us 335,000. Other result we are looking for is that if there is a second product type add to the cutting process, how much should we produce for each type to maximize profit while minimize the cost. The optimal amount of kilogram to produce that Solver gave us in normal circumstance is for type 1 product or the product we use in previous mentioned model, the amount should be 710 kilogram and type 2 product should be 740 kilogram.
And finally is the recommendations for the company improvements. As a result from our server, first, we would suggest the company to adopt new policies. As the company don't have to go with the full capacity as usual, they can just produce accordingly to the demand, which will eventually save the labor costs, electricity costs, as well as less inventories, which will eventually increase the profit as the costs are reduced. In other words, the company can save up to 10,000 baht compared with the full capacity policies. In terms of the exceeding demand or the best case scenario, we would suggest the company to extend the work shift to 7 days because it is less expensive compared to the outsourcing one. Therefore, if they choose to produce the leftover amount by themselves, by adding one additional workday, they would only have to pay about 33,000 more instead of the 40,000. In other words, they can save about 6,000 baht. And finally, for the amount of the product type in the third process, we would suggest the company to produce only 710 for the first type in order to maximize the profit because the type 1 is more expensive and take longer time to produce. And finally is for the second type, we would suggest them to produce about 740 to meet the optimal needs. And that's pretty much our presentation. Thank you.